Hello friends, I welcome you to the second lecture of quadratic equations. In the first lecture, we understood what is a quadratic equation, the roots of the quadratic equation and how do you find those roots. We'll continue from there and we'll understand the sum and product of the roots and the nature of roots in this particular lecture. So let's start with sum and product of the roots. It's a very simple concept. So if you have a general equation here, ax square plus bx plus c, then your sum of the roots is going to be minus b upon a and product of the roots will be c upon a. So just by looking at the equation you can say what is going to be the sum of the roots of this equation and what is going to be the product of the roots of this equation. And also you can reform your equation and write it something in this form where you have x square plus sum of the roots of the equation into x plus product of the roots equal to 0. Now nature of the roots. So every quadratic equation has two roots. In fact, the number of solutions of an nth degree equation is going to be equal to n. So if you have an nth degree equation on the left hand side, then the number of roots of this equation is going to be equal to n. So as it's a quadratic equation, the highest degree is 2. So the number of roots will always be equal to 2. Now these roots could be real, complex, and then your real roots could be equal or unequal. This is what you mean when you say what is the nature of the roots. It's real, complex, and then whether it's equal or not. So for an equation, the quantity d, which is b square minus 4ac, decides what is going to be the nature of the roots. This quantity is called discriminant. Let's look at the cases that we have in hand. So if your d is greater than 0, then your roots are going to be real and distinct. Take this equation for an example. Here your d is coming out to be equal to 1. Now since it's positive, so your roots are going to be real and distinct. We had taken this example in the last lecture and we came up with 2 and 3 as the solution of this equation, and as you can see, the roots of this equation are real and distinct. When you have your b square minus 4ac not a perfect square, here we had 1 which is a perfect square. If in case your d doesn't come out as a perfect square, then your roots are going to be irrational and they will appear as a conjugate pair, something like p plus under root q and p minus under root q. Then case 2, when your d is equal to 0, your roots are still going to be real but equal. Take this equation for example. If we find d for this equation, we have 0. So your roots are going to be real and equal, which is 1. So here we do not say that we have just one root. Here what we say is that we have two roots, both are real and equal in nature. Now your third case, when your d is less than 0, your roots are always going to be complex and unequal. Take this equation for example. Your d is coming out as minus 4. So since it's a negative quantity, your roots will be complex and unequal in nature. And if we try finding the roots of this equation using formula, what we'll have is 1 plus iota and 1 minus iota, which is complex in nature and is appearing as conjugate pair. So one thing to notice is that your complex roots always appear as conjugate pair. If one is 1 plus iota, then other will be 1 minus iota. So that's all we had for this lecture. This is what we are going to discuss in the coming lectures. Thank you so much for watching this video. Have a great day from Freeshiksha.